In elementary statistics, we defined the mode of a set of values as the most common value or values. If our values come from a random variable x, the mode will be the most common value of x, and this corresponds to the most probable outcome. So for example, suppose our experiment has a probability mass function. Let's find the mode, and we see that the most probable value is 3, so this is the mode. Or suppose we have an actual function for a PMF. So remember, trial and error always works. We can find the probability that n equals 1, 2, 3, 4, and so on. And so we find after which it appears the probability decreases. Now, since the probability that n equals 3 is the probability that n equals 4, and they are the most common, this distribution is bimodal with modes at 3 and 4. But do we really know that the probability is going to decrease after this? So as an alternative to computing each probability, we can compare the probability of x plus 1 and the probability of x. So we could find the difference and determine where this difference changes from positive, which would mean that f of x plus 1 is greater than f of x, to negative, which means that f of x plus 1 must be less than f of x. Or we could find the quotient and determine where this ratio changes from greater than 1, which means that f of x plus 1 is greater than f of x, to less than 1, which means f of x plus 1 is less than f of x. Actually, these are equivalent. If the ratio is greater than 1, then remember this is a PMF, so it has to be non-negative, so we can multiply across, and we find the difference is greater than 0, and conversely. Since it's possible we might be able to remove common factors, we always start with the ratio. So again, let's consider our problem again, and even though we've solved it, remember, if the only tool you have is a hammer, then every problem has to be treated like a nail, even if it's opening a jar of pickles. So let's look at the ratio between what we can think about as consecutive probabilities, using our probability mass function. And note that we can do a lot of simplification here, so we get we want to find when this ratio switches from being greater than 1 to being less than 1. So we'll set that ratio equal to 1 and solve. So we should always interpret our results. So the ratio is 1 when x is equal to 3. And so that tells us the ratio between the probabilities when x is equal to 3 plus 1 to the probability x equals 3. That quotient is 1. And so the probability that x equals 4 is equal to the probability x equals 3. And since these are the most common values, the modes are going to be x equals 3 and x equals 4.